Callisto, the third largest moon in our solar system, orbits Jupiter at a distance of over 1.8 million kilometers. It's even larger than Mercury, and yet it remains virtually unknown to us compared to its more famous sibling, Europa. But why is this enigmatic world so intriguing? Discovered by Galileo Galilei in 1610, Callisto has a diameter of about 4,820 kilometers. That's over 3,000 miles, large enough to dwarf Mercury and even give Earth's moon a run for its money. Yet, despite its size, our knowledge of this icy world remains scarce. Imagine the vast expanse of Callisto's surface, untouched by time and unchanged for billions of years. It bears the scars of ancient impacts, yet beneath this frozen crust lies a secret that has captured the imagination of scientists. The Galileo mission, which studied Callisto from 1995 to 2003, revealed intriguing evidence suggesting that beneath its icy exterior lies a vast subsurface ocean. This discovery hints at the potential habitability of this distant world. But what makes Callisto truly remarkable is not just its size, but also its composition and history. Its surface, the oldest in the solar system, dates back more than 4 billion years, making it a time capsule of sorts. As we delve deeper into this enigmatic world, we find that Callisto is not just an icy moon, but a cosmic puzzle waiting to be solved. And as the mysteries of this distant world continue to unfold, one question remains: could there be life lurking beneath its frozen surface? So, join us on this celestial journey as we unravel the secrets of Callisto, a world that holds promise and mystery in equal measure. Before we begin, a small request. Most of the people listening tonight aren't subscribed. If this channel has ever helped you drift off, take a moment to subscribe. It's free, it helps this channel more than you'd think, and you can always change your mind later. And if you feel like it, leave a comment telling me where in the world you're listening from and what time it is where you are. I love reading them. One more thing before we begin. I'm also a co-founder of a sleep app, built to be the most affordable one out there. No ads, ever. Just sounds and stories made to help you sleep. It may not be released yet as this video goes up, but if you're watching a little later, it might be out by now. Just search for it. It should be easy to find. It works on iPhone, Android, and everything in between. Downloading it is the best way to support this channel. As we journey through the cosmos, let's explore one of Jupiter's most intriguing moons, Callisto. This distant world presents us with a surface that is both mysterious and heavily cratered. Callisto's surface, the oldest in our solar system, boasts over 150 impact craters larger than 30 kilometers in diameter. These colossal markers of ancient cosmic events provide a glimpse into the moon's long and tumultuous history. Compositionally, Callisto is a fascinating mix, approximately 40% ice and 60% rock. This icy, rocky blend gives the moon its unique character and contributes to the intriguing possibility of subsurface oceans. The surface temperature on Callisto fluctuates between a frigid 65 degrees CC, 265 degrees CC, and an even colder 139 degrees C, 208 GZC. These extreme conditions paint a picture of an environment that, while seemingly inhospitable, hints at the potential for hidden life beneath its icy surface. So, let's continue our exploration and unveil the mysteries that this ancient moon holds within its icy depths. Join us next as we take a closer look at Callisto's potential to harbor life in its vast hidden oceans. The Galileo spacecraft, launched in 1989 and operated until 2003, sent back crucial data about Jupiter's largest moon. Among the mission's discoveries was a strong indication of liquid water buried beneath Callisto's crust. But what if there's more to this icy moon than meets the eye? Could the frozen water harbor something extraordinary beneath its surface? Think of Earth's polar regions. There's ice on top, but below it lies a vast ocean teeming with life. Now imagine that same scenario on Callisto. Scientists suggest that the icy shell of Callisto could be acting like a lid, trapping a liquid ocean beneath it. If true, this ocean might extend all the way down to its rocky core. This is where things get fascinating. Despite being so far from the Sun, Callisto's subsurface ocean might be kept warm by tidal forces caused by Jupiter's immense gravitational pull. But what does this mean for the possibility of life? Could simple microbes be lurking in Callisto's hidden depths? We know from Earth's extremophiles that life can thrive in conditions once thought uninhabitable. So who knows what secrets might lie hidden beneath Callisto's icy exterior? This is where our understanding of Callisto reaches its limit and curiosity begins to stir. What mysteries might be waiting in this distant ocean, patiently enduring the cold? As we continue our exploration, one thing is clear. Callisto's subsurface ocean holds tantalizing clues to its past and hints at a future full of possibilities. Deep within the crust of Callisto lies a secret world hidden from our view. At its heart, a small rocky core, tiny compared to Earth's molten center. Surrounding it is an icy layer, miles thick. But this is no ordinary ice. Scientists believe there could be liquid water beneath that frozen shell. Imagine, if you will, the vast ocean hidden under the polar caps of our own world. Now picture a similar layer, tucked away beneath Callisto's icy surface. This subsurface ocean might stretch for miles and miles, harboring secrets that could rewrite the story of life in our solar system. As we delve deeper into Callisto's mysteries, one thing becomes increasingly clear. This icy moon might hold the key to unlocking the secrets of our cosmic neighborhood. And with that thought, we prepare to take another step into the unknown depths of Callisto's hidden world. Scientists are eager to explore this mysterious world, hoping to uncover conditions that might support microbial life. The Europa-Clipper mission, scheduled for launch far in the future, will also investigate the habitability of Callisto's subsurface ocean. This mission could provide crucial insights into the possibilities for life on this distant moon. NASA's studies of Europa have already shown us that icy moons can harbor vast subsurface oceans, and these oceans might be teeming with life. But what if there is life on Callisto? It would be a revolutionary discovery, opening up the question of life beyond Earth in an entirely new way. Scientists are not just dreaming, they are actively working to understand if this icy moon holds the key to extraterrestrial life. Galileo's life and work have been the subject of numerous documentaries and studies, and his discovery of Callisto has opened up a whole new chapter in our exploration of the universe. As we delve deeper into the mysteries of Callisto's subsurface ocean, we can't help but wonder, are we alone in the universe? And if not, what forms might life take among the icy moons of Jupiter? In this vast cosmic tapestry, Callisto's habitability could be a vital thread that helps us understand our place in the universe and perhaps even find our distant cousins. And as we prepare for future missions like Europa-Clipper, we are filled with a sense of wonder and anticipation for what secrets might lie hidden beneath the icy crust of Callisto. With each new piece of information, we take another step closer to unraveling the mysteries of our cosmic neighbors and perhaps finding answers to one of humanity's greatest questions: are we alone? The Cassini mission, primarily focused on studying Saturn and its moons, also provided valuable data about Callisto. But it wasn't until the New Horizons mission, known for its groundbreaking study of Pluto, that we gained further insights into Callisto during its flyby of Jupiter's moons. These missions have been instrumental in piecing together the puzzle of Callisto's composition and potential habitability. The name Callistos echoes through the halls of Greek mythology, tracing back to the story of Artemis's companion, Callisto. In these tales, Callisto is depicted as a nymph and one of Artemis's closest companions. She vows to remain chaste, but her devotion is tested when Zeus takes on the form of Artemis and seduces her. Discovering her pregnancy, Callisto hides it from Artemis for fear of retribution. Eventually, the secret is revealed to Artemis, who in anger transforms Callisto into a bear. This mythological figure's name was bestowed upon Jupiter's second largest moon by Galileo himself as a nod to the ancient tale of Artemis and her loyal companion. The connection between this mythological narrative and the discovery of the moon brings an added layer of cultural richness to our exploration of Callisto's vast subsurface ocean. As we delve deeper into understanding this celestial body, the story of Callisto serves as a reminder that even in the distant reaches of space, human history and mythology can leave their mark. This ancient tale adds a poetic dimension to our modern scientific quest, inviting us to see beyond the data and into the realms of human imagination and storytelling. Perhaps this mythological legacy can inspire new questions about our universe's mysteries, a testament to the enduring power of myth in shaping our understanding. The continued exploration of Callisto holds the promise of unveiling even more secrets about its vast subsurface ocean and the potential for life within it. Future missions will likely involve increasingly sophisticated technologies that can delve deeper into the moon's interior, providing invaluable data on its habitability. Perhaps most exciting is the potential for these missions to reveal whether Callisto's subsurface ocean shares any similarities with Earth's oceans, offering clues about the origins of life itself. This could revolutionize our understanding of how life might have emerged on other celestial bodies. With each new discovery, the allure of Callisto grows stronger. As we continue to peer into its mysteries, we inch closer to answering one of the most profound questions in our quest for extraterrestrial life. Are we alone in the universe? As these missions unfold, they will not only expand our scientific knowledge, but also ignite public interest and engagement with space exploration. The captivating story of Callisto's subsurface ocean is just beginning to unfold. What awaits us in the depths of Callisto? Will we find signs of life, hints at the building blocks of existence, or something entirely unexpected? The future of Callisto exploration promises to be as awe-inspiring as it is revelatory. And so, we look ahead with anticipation and wonder. As new missions take flight, they will carry our collective hopes and dreams into the cosmos, seeking answers to questions that have captivated humanity for centuries. In this grand endeavor, we stand on the shoulders of giants like Galileo himself, whose pioneering spirit continues to guide us as we venture into the unknown. What will the future hold for Callisto and its enigmatic subsurface world? Only time and exploration will tell. The discovery of Callisto's subsurface ocean is more than just a fascinating find. It has profound implications for our understanding of the origins and distribution of liquid water in the cosmos. This cosmic significance extends far beyond Callisto itself, as it reveals intriguing possibilities about the potential habitability of other celestial bodies. Ever since the Galileo mission first hinted at its existence, scientists have been intrigued by this vast body of water hidden beneath Callisto's icy crust. This liquid water, if confirmed, would challenge our long-held beliefs about where and how life might emerge in the universe. The search for liquid water beyond Earth has been one of the most exciting quests in planetary science. Callisto's vast subsurface ocean offers a unique laboratory to study the potential habitability of environments that may exist under the icy shells of other moons and planets. Scientists believe that understanding Callisto's subsurface ocean could provide crucial insights into the distribution and origins of water in our solar system, and possibly beyond. This discovery underscores the cosmic significance of Callisto and its subsurface ocean, opening doors to new realms of exploration and understanding in planetary science. Think about it. If we can find a vast body of liquid water beneath the icy crust of a moon like Callisto, what other surprises might be waiting for us in the dark recesses of our cosmic neighborhood? Each new discovery about Callisto's subsurface ocean adds another layer to our ever-deepening understanding of the universe and its potential for harboring life. As we continue to explore this enigmatic moon, we inch closer to unraveling the mysteries of the universe and our place within it. And so, the cosmic significance of Callisto's subsurface ocean lies not just in its own discovery, but in what it reveals about the possibilities that await us in the vast expanse of space. This moon's hidden world is a testament to how much there is left to explore, learn, and perhaps even one day call home. Beneath the icy surface of Jupiter's moon, Callisto lies a vast subsurface ocean, hidden from view but teeming with potential. This hidden world is influenced by powerful tidal forces, which play a crucial role in shaping its environment and determining its habitability. Tidal forces on Callisto are primarily generated by the gravitational pull of Jupiter and Io, Jupiter's volcanically active moon. The massive size and proximity of Jupiter exert a significant gravitational influence on Callisto, causing the moon to bulge slightly towards and away from the planet. This constant flexing generates heat through a process known as tidal heating. The heat generated by this tidal flexing may be enough to maintain Callisto's subsurface ocean in a liquid state, making it potentially habitable for some forms of life. But tidal forces on Callisto are not just about Jupiter. Io, with its intense volcanic activity, also exerts a powerful gravitational pull, contributing to the complex interplay of forces that shape this icy world. These tidal forces are so strong that they can cause slight variations in Callisto's orbit and rotation, further influencing the stability of its subsurface ocean. Understanding how these forces interact is key to understanding the potential habitability of Callisto's vast and hidden world beneath its frozen exterior. So as we explore the cosmos, let's remember that even in the most distant corners of our solar system, forces are at work shaping worlds and creating conditions that could one day support life. And maybe, just maybe, Callisto's hidden ocean holds secrets yet to be discovered, waiting for the day when we can call it home. For now, the vast and icy world of Callisto continues its silent dance with Jupiter and Io, shaped by the powerful and mysterious forces that surround it. Beneath Callisto's icy surface, a vast subsurface ocean swirls in the moon's depths, a testament to the forces that have shaped it over billions of years. Heat flow plays a crucial role within this ocean, determining not only its composition, but also its potential to harbor life. This heat is generated from various sources, both external and internal. While tidal forces contribute to internal heating, the primary heat source for this subsurface ocean is thought to be the radioactive decay of elements within Callisto's core. This ongoing process creates a steady thermal gradient that influences the ocean's temperature and composition. The heat flow from these sources helps to maintain the liquid state of Callisto's subsurface ocean, despite the moon's frigid exterior temperatures. Without this internal heating, the water would likely freeze solid, making any form of life impossible. Imagine, for a moment, standing on the edge of Callisto's Valhalla crater, one of the largest impact features in the solar system. The surface temperature here can plummet to as low as 165 degrees C, C267 degrees Celsius, yet beneath this icy shell, the ocean remains liquid and potentially habitable. The presence of a subsurface ocean on Callisto raises intriguing questions about the potential for life to exist within its depths. The heat flow dynamics that maintain this liquid environment are critical in shaping the conditions necessary for habitable zones where microorganisms could thrive. To begin with, let's consider the mineral content. The subsurface ocean on Callisto is believed to be rich in various minerals dissolved within it. These minerals, such as sodium chloride and magnesium sulfate, are crucial for maintaining the chemical balance necessary for life. But it's not just about the minerals. Scientists also suspect that this ocean might contain organic compounds, the building blocks of life as we know it. Imagine tiny fragments of amino acids or nucleotides floating in this vast underwater world. These organic molecules could have been delivered via impacts from other celestial bodies or even created within the moon's interior. Now, let's turn our attention to how these chemicals react with the rocky layers beneath them. The minerals and organic compounds in this ocean are constantly interacting with the surrounding rock. This interaction is dynamic and could lead to fascinating chemical reactions that might support life. Picture a slow dance of elements within Callisto's depths, a delicate balance maintained over eons. But how do these interactions contribute to the potential habitability of this environment? The heat flow dynamics we mentioned earlier play a crucial role here. These dynamics not only maintain the liquid state of the ocean, but also drive chemical reactions that could create habitable zones, pockets where microorganisms might find a welcoming home. To put it simply, the chemical environment within Callisto's subsurface ocean is far from inert. It's a living, breathing world of its own. Now, take a moment to breathe and imagine the possibilities hidden within this unseen world. Could there be life forms thriving deep beneath Callisto's icy crust? The chemical composition and reactivity suggest that it might just be possible, a tantalizing hint at the mysteries yet to be discovered. Beneath Callisto's thick, icy crust lies a vast subsurface ocean, teeming with secrets waiting to be revealed. This hidden world, shielded from the harsh radiation of space, could harbor life forms that have evolved and thrived in its depths. Scientists are particularly interested in identifying biosignatures, indicators of life that can be detected from afar. Organic molecules, such as amino acids and complex carbohydrates, could provide a clear sign of life's presence in the ocean. Additionally, microbial mats, dense layers of single-celled organisms, might exist on the seafloor, hinting at an ecosystem teeming with tiny creatures. The detection of metabolic byproducts like methane could be another significant clue, indicating that some form of life is actively at work within the ocean's depths. To find evidence of this habitable world, scientists are employing sophisticated instruments and methods. These include spectrometers that can analyze the chemical composition of the ocean's plumes, which could contain vital clues about life below. Moreover, exploring these subsurface realms involves using probes that can delve deep into the ice to sample the ocean directly and collect data on its composition and biological activity. With each new discovery, we move closer to unraveling the mysteries of Callisto's ocean, a testament to the incredible complexity and potential for life within our solar system. As we continue to explore these distant worlds, who knows what wonders await us just beneath the surface of an icy moon? The exploration of Callisto's subsurface ocean begins with a question: how did this vast reservoir of liquid water come to exist? To understand the origin of Callisto's ocean, we must consider the powerful influence of Jupiter's magnetic field. Just like Earth's, Jupiter's magnetic field generates a protective bubble around its moons, shielding them from the solar wind's charged particles. This magnetic shielding allows Callisto to retain heat over time, creating conditions favorable for a subsurface ocean to form. But the formation of Callisto's ocean isn't solely dependent on Jupiter's magnetic field. Tidal forces also play a significant role. The tug-of-war between Jupiter and its massive moons, especially Io, causes Callisto to stretch and compress slightly with each orbit. This process generates heat within the moon's interior. Over millions of years, this internal heat has been enough to melt the ice beneath Callisto's surface and create a subsurface ocean that extends to a depth of several kilometers. It opened up possibilities that a similarly sized and distant moon like Callisto could also harbor a vast liquid reservoir beneath its icy exterior. But unlike Europa, which has an ocean sandwiched between layers of ice and rock, Callisto's interior is believed to be more complex, with a small rocky core surrounded by an icy mantle. This complexity suggests that the formation of Callisto's ocean may involve additional geological processes beyond just tidal heating and magnetic field shielding. The discovery of a subsurface ocean on Callisto, Jupiter's second-largest moon, has piqued the interest of scientists worldwide. This vast body of water, believed to be as large as all the Earth's oceans combined, could potentially harbor life in its depths. But what makes this icy moon's ocean so intriguing is not just its sheer size, it's the hints of hydrothermal activity deep beneath the surface. The thickness of this ice shell, estimated to be around 300 kilometers, ensures that the radiation levels are significantly reduced by the time they reach the ocean below. Scientists believe that the protective properties of this ice shell make it possible for hydrothermal activity to exist within the subsurface ocean, creating a potentially habitable environment. Research suggests that water from the ocean could periodically interact with this icy layer through processes like convection or geothermal heat, further enriching the ocean's composition and fostering conditions conducive to life. Theoretical models propose that these interactions could lead to the formation of various compounds essential for life, such as methane and hydrogen sulfide, which could then be used by any potential microbial ecosystems within Callisto's ocean. Despite the harsh conditions on its surface, the ice shell plays a critical role in maintaining a stable environment deep below where life might just be taking its first steps. As we continue to explore Callisto and other icy moons, the ice shell's protective role stands as a testament to the incredible ways our universe supports life in even the harshest environments. It is this delicate balance of protection and interaction that gives Callisto's subsurface ocean its unique allure, drawing us ever closer to unraveling the mysteries of life beyond Earth. One of the key objectives of this mission is to search for biosignatures, signs of life that can be detected remotely. For Callisto, this includes methods tailored to its unique conditions. Researchers are looking for indications, such as unusual compositions of gases in the icy plumes that erupt from the moon's south pole. The Europa Clipper will be equipped with sophisticated spectrometers to analyze these plumes for any organic compounds or other biological markers. This mission represents a significant leap forward in our ability to investigate the habitability of icy moons. But the search for life on Callisto is fraught with challenges. The moon's extreme cold and the thick ice crust pose significant obstacles to detecting biosignatures. Scientists must also consider whether any signals detected are of biological origin or simply geological in nature. Despite these hurdles, the potential discovery of life on Callisto would be a monumental step forward for astrobiology. It could provide insights into how life might have emerged and evolved in such an environment. For now, we can only imagine what wonders lie hidden beneath the icy surface of Callisto. Future missions, building on the data from Europa Clipper and other space probes, will continue to refine our understanding of this mysterious world. This journey of exploration and understanding reminds us that our quest to find life in the universe is not just a matter of curiosity, but also a testament to our own insatiable desire for connection and knowledge. First detected by the Galileo mission from 1995 to 2003, this vast reservoir of liquid water exists beneath Callisto's frozen crust. It is a testament to the complex dynamics at work within this seemingly barren moon. The presence of this subsurface ocean could hint at unique atmospheric processes. On Earth, oceans play a crucial role in shaping our atmosphere through evaporation and condensation. Might Callisto's ocean have similar effects? One intriguing possibility is that tides within the subsurface ocean could influence atmospheric composition. Tidal forces, driven by Jupiter's gravitational pull, could cause liquid water to rise and fall, creating a rhythmic movement that might affect how gases dissolve and release into the atmosphere. Moreover, the movement of Callisto's icy shell could further complicate this interaction. As the ice shell shifts due to tidal stresses, it might expose pockets of liquid water that could alter local atmospheric conditions temporarily. These dynamic interplays between Callisto's subsurface ocean and its atmosphere raise fascinating questions about the Moon's potential habitability. If life were to exist beneath the icy crust, how might it interact with or be influenced by these atmospheric processes? For now, our understanding of this complex interaction remains a work in progress. As we continue to explore the Jovian system and its moons, each new discovery brings us one step closer to unraveling the mysteries that lie hidden beneath Callisto's frozen exterior. Perhaps one day we will find concrete evidence of life within this subsurface ocean, shedding light on how it has adapted to and thrived in such an extraordinary environment. Until then, the interaction between Callisto's vast ocean and its tenuous atmosphere serves as a tantalizing clue to the potential for habitability deep within Jupiter's icy moons. This ocean, thought to be around 250 kilometers deep, is protected by a layer of ice and rock, creating conditions that might harbor life. Scientists are particularly interested in extremophiles, organisms capable of surviving extreme environments. If they exist on Earth, why not elsewhere? Callisto's ocean might contain microbes that thrive in conditions similar to those found in the deep-sea hydrothermal vents on Earth. The composition of Callisto's ocean, rich in salts and minerals, could support a variety of extremophile bacteria and archaea. These tiny organisms could use the chemical energy available in the ocean to sustain themselves, much like the extremophiles found near deep-sea vents on our planet. As missions like Europa-Clipper and New Horizons continue to explore Jupiter's moons, we inch closer to unveiling the secrets of Callisto's vast ocean. The astrobiological implications are profound. If life exists in this hidden world, it would redefine our understanding of habitability and the potential for extraterrestrial life. Callisto's ocean holds immense promise and curiosity. What wonders lie beneath its frozen surface? Only future missions will tell us more. At Callisto's core lies a small, rocky nucleus encased within layers of ice and possibly liquid water. The heat generated by this core is transferred upward through the mantle. This process creates a geothermal gradient, a gradual decrease in temperature from the hotter interior to the colder exterior. The heat transfer helps maintain the stability and temperature of Callisto's subsurface ocean. The gradient within Callisto is crucial because it affects the thermal conditions that could support life within its vast, hidden ocean. Each layer of ice and water within Callisto carries the potential for life as we know it, shaped by the subtle yet powerful forces of its interior. But there's another intriguing possibility that scientists are exploring: the presence of hydrothermal activity. Just like on Earth's seafloor, this activity could drive the formation of towering plumes. These plumes might shoot up from the ocean's depths, carrying with them clues about what lies beneath. It's a promising avenue for understanding whether the conditions necessary for life might exist there too. Imagine these plumes reaching into space, carrying with them not just water, but also any traces of life within the ocean. These traces could offer scientists a way to detect signs of life without even having to set foot on Callisto. Like Earth, Callisto is seismically active, a fact that has puzzled scientists for years. The tectonic activity of this distant moon is far more subdued than on our planet, but no less fascinating. Seismometers aboard the Galileo probe detected faint tremors, indicating that Callisto's interior is far from static. These quakes, though mild, hint at a world of geological complexity hidden beneath its icy crust. Scientists hypothesize that these quakes are the result of tectonic plates moving slowly and steadily, much like Earth's plates, but at a glacial pace. The presence of fault lines on Callisto's surface further supports this theory. These fractures, though not as dramatic as those on Earth, are evidence of ancient tectonic forces at work. While we can't say for certain without more data, it's plausible that these movements are influencing the ocean, perhaps causing slight disturbances that ripple through its liquid depths. The Europa-Clipper mission, set to launch far in the future, aims to shed more light on these enigmatic forces. Perhaps it will reveal whether Callisto's tectonic activity truly affects its vast, hidden sea. For now, we are left to wonder at the potential connections between the tectonic dance of Callisto and the mysterious waters that lie beneath its frozen surface. To understand why this ocean exists and how it might be habitable, we need to consider Jupiter's gravitational influence on Callisto. Jupiter, with its immense mass, exerts a powerful tidal force on its moons. These forces cause the solid surface of Callisto to bulge and flex in response to Jupiter's pull. This constant tugging creates friction within the icy crust, generating heat. That heat, over billions of years, has led to the melting of the ice beneath Callisto's surface, giving rise to a subsurface ocean. This liquid body is not static. It's subject to the same gravitational influences that shaped it in the first place. Jupiter's gravity causes tides in Callisto's ocean, just as the Moon does with Earth's oceans. These tidal forces are immense due to Jupiter's size and proximity. They continually reshape and stir the liquid beneath the surface. These gravitational interactions play a crucial role in maintaining Callisto's subsurface ocean. Without Jupiter's tidal influence, the heat generated from within might not be enough to sustain this liquid reservoir over such long periods of time. In a sense, Callisto's subsurface ocean is a testament to the dynamic interplay between gravity and the geological evolution of worlds beyond Earth. It reminds us that even in the seemingly static realms of space, forces are constantly at work, sculpting and shaping our celestial neighbors. This ocean, locked away beneath an icy exterior, holds tantalizing clues about the potential habitability of worlds beyond Earth. And it's all thanks to Jupiter's persistent gravitational pull. For now, we continue to unravel the mysteries of this hidden world and its vast, gravity-shaped ocean. What secrets lie beneath Callisto's frozen surface? Only time and further exploration will tell. Deep within Callisto's heart lies a secret, a vast subsurface ocean stirred by the Moon's core interaction. The Galileo mission's discovery of this hidden world sparked questions about its origins and dynamics. One key factor is the magnetic field generated by Callisto's core, which scientists believe could shield life within. This magnetic shield can deflect charged particles from Jupiter's intense radiation belts, providing a safer environment. But the core interaction extends beyond magnetic fields. The Moon's spinning core also influences its ocean's behavior. This constant movement could help sustain life by mixing nutrients and maintaining a stable environment. Each discovery brings us closer to understanding the potential habitability of this vast, gravity-shaped ocean. And as we uncover these secrets, we find ourselves drawn into the profound question, are we alone in our solar system? Cosmic rays are high-energy particles that travel through space at nearly the speed of light. These rays originate from various sources, including supernovae and active galactic nuclei, and they penetrate deep into Callisto's icy crust. The constant bombardment of cosmic rays has significant implications for the chemistry of Callisto's vast subsurface ocean. Scientists believe that cosmic rays interact with the water molecules in the ocean, breaking them down into simpler compounds such as hydrogen peroxide. These interactions can alter the composition of the ocean over time, creating a unique environment that may be vastly different from what we find on Earth. Despite the harsh conditions, some forms of microbial life might still thrive in this environment, fed by the energy from these chemical reactions. As we continue to explore the depths of Callisto's ocean, understanding the role of cosmic rays becomes crucial in our quest to unravel its secrets. By doing so, we might discover not only the building blocks of life, but also the potential habitability of this distant world's vast subsurface ocean. To understand the potential habitability of Callisto's subsurface ocean, we must delve into its geological evolution. This journey back in time will reveal how this distant world has transformed over billions of years. Despite its complex surface, Callisto lacks significant tectonic activity. Unlike other moons and planets in our solar system, there are no signs of plate movement or volcanism on this distant world. This lack of tectonic activity has preserved Callisto's surface and subsurface features, allowing us to study them in their near-original state. It's as if time itself has slowed down for this ancient moon. With its vast subsurface ocean, Callisto presents a unique opportunity to study the evolution of water in our solar system. But how has this delicate environment remained intact over billions of years? One factor lies in the moon's prominent impact craters, which serve as time capsules for understanding the forces that have shaped it. Research into Callisto's subsurface has revealed that major impacts have occurred at an average rate of one every 10 million to 100 million years, leaving their marks across its surface. Despite these frequent events, the stability of Callisto's subsurface ocean is remarkable. The lack of tectonic activity has allowed the water to remain largely undisturbed. Scientists speculate that the dense ice layer on top of the ocean could act as a protective shield, absorbing the force of these impacts and preserving the water beneath. As we continue to unravel the mysteries of this ancient moon, one thing is certain: its vast reservoir of water holds secrets that are crucial for understanding our solar system's past and future. And though impact craters dot its surface, the resilience of its subsurface ocean is a testament to the enduring power of water in our cosmic neighborhood. For now, we stand on the brink of new discoveries that will shed light on how life might have emerged in such distant realms. Deep within Callisto's icy crust lies a vast subsurface ocean, believed to be one of the largest in our solar system. Studying this ocean means understanding the complex environment it resides in, including the role of Callisto's magnetic field. Callisto's magnetic field is relatively weak compared to Earth's, measuring only about 30 microtesla. Despite its weakness, this magnetic field is significant for the ocean below because it interacts with Jupiter's powerful magnetosphere. Jupiter's magnetic field is one of the largest in our solar system, stretching millions of kilometers into space. This interaction could shield Callisto's subsurface ocean from harmful cosmic rays and charged particles. Imagine a vast, protective umbrella extending over the moon's surface, safeguarding the precious liquid water beneath. These shielding effects are crucial in understanding the potential habitability of Callisto's ocean and its role as a sanctuary for life. Callisto's orbit, it turns out, plays a crucial role in shaping and sustaining the subsurface ocean beneath its icy crust. Orbiting Jupiter at an average distance of about 1.88 million kilometers, Callisto is locked in a complex dance with the gas giant. The most significant influence comes from Jupiter itself, specifically its immense gravity and tidal forces. These forces are so powerful that they cause Callisto to bulge slightly at the points facing towards and away from Jupiter. But what makes Callisto's case particularly interesting is its orbital resonances. Callisto, along with the moons Io, Europa, and Ganymede, are locked in a complex gravitational dance called orbital resonance. This resonance means that for every 4 orbits Callisto makes, Europa completes 2, and Io completes 1. These synchronized movements amplify the tidal forces acting on Callisto, enhancing the heating effect. So, Callisto's orbit, with its resonances and tidal forces, is not just a path in space, it's a lifeline sustaining the potential for life in the depths of an icy world. Callisto is not the only Galilean moon hiding a vast ocean beneath its icy surface. Io, Europa, and Ganymede also harbor subsurface seas, each with unique compositions and depths. Europa, on the other hand, is believed to have a layer of liquid water beneath its icy crust. This ocean is estimated to be about 100 kilometers deep, 10 times deeper than Earth's Mariana Trench. These oceans, though vastly different in composition, share one commonality: the potential for life. The tidal forces exerted by Jupiter on these moons create heat that could sustain habitable environments within their icy depths. Scientists believe that the extreme conditions of Io's magma ocean may support life forms unlike any we know on Earth. In contrast, Europa's liquid water could be home to simpler microbial organisms. The study of these subsurface oceans offers a glimpse into the vast possibilities of life beyond Earth, expanding our understanding of the cosmos and our place within it. So, while each Galilean moon's ocean is unique in its own right, they all contribute to a larger story of life's potential resilience and adaptability. One of the critical factors maintaining Callisto's subsurface ocean is a phenomenon known as tidal heating. This process occurs due to the gravitational pull exerted by Jupiter, the planet that Callisto orbits. You might be familiar with how tides on Earth are influenced by the Moon and the Sun. In a similar manner, Jupiter's immense mass creates powerful tidal forces on Callisto. As Callisto orbits Jupiter, the giant planet's gravity stretches and compresses the Moon, much like how squeezing a rubber ball can cause it to deform. This constant tugging and releasing of Callisto's surface generates heat deep within the Moon. Scientists believe this internal friction is significant enough to keep parts of Callisto's subsurface liquid. To put this into perspective, consider how you might feel after a strenuous workout. The heat generated by your muscles working hard is akin to the heat produced within Callisto due to Jupiter's gravitational influence. This tidal heating not only helps maintain the liquid state of Callisto's ocean, but also contributes to geological activity on the Moon. For instance, the heat generated can lead to the formation of cracks and faults on Callisto's surface. These fissures allow water vapor from the subsurface ocean to escape and form beautiful plumes that can reach several kilometers high. The interaction between Jupiter's magnetic field and Callisto's subsurface ocean has been a topic of interest for scientists studying the Jovian system. This magnetic field can induce electrical currents within the conductive fluid of Callisto's subsurface ocean, a phenomenon known as magnetohydrodynamics. These induced currents can lead to unique chemical reactions within the ocean, potentially affecting its composition and stability over time. This data provides additional insights into how external magnetic fields can shape the environments of distant moons like Callisto. The Juno mission, currently studying Jupiter, also contributes to our understanding of these dynamic interactions within the Jovian system. As we continue to explore and learn more about Callisto's vast subsurface ocean, the complex interplay between its internal environment and external factors like Jupiter's magnetic field becomes increasingly fascinating. The recent discovery of plumes on Europa has sparked intrigue and curiosity about the dynamics beneath the surface of other moons, including Callisto. This vast body of liquid water has been a prime target in the search for extraterrestrial life due to its potential habitability. One fascinating phenomenon observed on Europa is the presence of plumes, huge jets of water vapor erupting from fissures near the moon's south pole. These plumes are believed to be caused by tidal forces exerted by Jupiter, which create enormous stresses within Europa's icy shell, leading to cracks and geysers that spew water vapor into space. The detection of these plumes has been a significant breakthrough in understanding the internal dynamics of icy moons. They provide vital clues about the composition and activity within subsurface oceans. Given Callisto's similarities to Europa, including the presence of an enormous subsurface ocean, scientists have begun to explore whether Callisto might also exhibit plume activity. Both moons are subjected to intense tidal forces from Jupiter, which can create significant stresses within their icy shells. Intriguingly, Callisto's subsurface ocean is thought to be more isolated than Europa's, potentially shielded by a thicker layer of ice. This could make it challenging for plumes to erupt, but it also raises the possibility of unique geological processes at play. For now, the search for Europa-like plumes on Callisto continues, promising a glimpse into the intricate dance between Jupiter's gravitational forces and the vast hidden oceans of its moons. Perhaps one day, we will unveil the secrets buried beneath Callisto's icy surface. Secrets that might not only reshape our knowledge of this distant world, but also hint at the existence of life in the far reaches of our solar system. So, let us keep exploring, one step at a time, unraveling the universe's secrets and finding our place within this grand performance. For Callisto, this gravitational ballet results in a dynamic ocean environment where tides rise and fall, generating heat and stirring the waters within the subsurface ocean. This constant churning could be key to fostering conditions that might support life as we know it. The sheer magnitude of these forces is staggering. Jupiter's gravity is so powerful that the tidal stresses on Callisto's icy crust are equivalent to those experienced by a human carrying 10 times their body weight. It's like walking under the load of a small car. The constant ebb and flow also mixes the ocean waters, ensuring that any nutrients or chemical ingredients vital for life are distributed evenly. It's as if someone is continuously stirring a pot of soup to ensure every bite tastes just right. So, the dance of Callisto and Europa around Jupiter isn't just a celestial waltz. It's a complex interplay that shapes an entire world hidden beneath an icy shell. And as we delve deeper into these mysteries, we come one step closer to understanding our place within this grand, cosmic performance. Dive beneath Callisto's icy crust, and you'll find an ocean vast enough to cover all of Earth. This subsurface sea isn't just a curiosity, it's a potential reservoir of life. But what shapes the chemistry of this hidden world? The key lies in Ejecta, the debris hurled into space by colossal impacts. When a massive object slams into Callisto, it hurls a storm of rock and ice fragments into the sky. These pieces, known as ejecta, can travel immense distances before raining back down. As these fragments fall through Callisto's thin atmosphere, they collide with other particles, breaking apart and releasing a wealth of volatiles, gases like water vapor, methane, and carbon dioxide. These volatile-rich clouds sink back into the ocean through large cracks in Callisto's surface. Some of these fissures, like Valhalla, stretch wider than Earth itself. Once inside, the ejecta and their volatile cargo enrich the ocean with vital ingredients. Water vapor condenses into liquid water, methane could form complex organic compounds, and carbon dioxide might react to form carbonates, all building blocks essential for life as we know it. Each impact event contributes a unique chemical signature, layering the ocean with diverse elements over billions of years. This interplay of ejecta and volatiles shapes an entire world hidden beneath an icy shell, unveiling clues to Callisto's potential habitability. So, as we continue our cosmic journey, we carry with us the knowledge that the very impacts that have scarred Callisto may also be the key to its life-giving secrets. Beneath the frozen surface, volcanic activity once played a significant role in shaping Callisto's geological history. Ancient lava flows and heat from this volcanic past could have contributed to the stability of Callisto's subsurface ocean. Heat transfer from these ancient flows might have helped maintain liquid conditions within the vast sea underneath Callisto's crust. Imagine hydrothermal vents similar to those found on Earth's seafloor, spewing warm water into the icy sea. These could provide a haven for potential life forms. So as we ponder the mysteries of this distant world, we carry with us a tantalizing thought. Beneath the frozen silence of Callisto, there might be an ocean teeming with life's building blocks. And in this vast cosmic tapestry, every new discovery is a thread that brings us closer to understanding the universe's grand design. Valhalla spans over 3,000 kilometers across and has a central peak that rises to about 20 kilometers high. The sheer force of these impacts has significantly shaped Callisto's icy shell. The ice sheet on Callisto is estimated to be around 100 kilometers thick. When these colossal impacts occur, they can breach through the ice and even penetrate into the underlying rocky core. The energy released by such events can mix materials from the surface down to the subsurface ocean, potentially altering its chemical composition. Scientists believe that over time, this process of impact erosion has introduced various elements and compounds into the ocean, contributing to its complex chemistry. Despite being far from the sun and trapped beneath thick layers of ice, this subsurface ocean holds tremendous scientific interest due to its potential habitability. Future missions like Europa-Clipper, set for launch far in the future, will provide more insights into the habitability of this vast oceanic environment on Callisto. And so, the tale of this distant moon unfolds, layer by layer, revealing a cosmos where even the smallest impacts can reshape entire worlds. It found evidence of a subsurface ocean beneath Callisto's icy exterior. This vast body of water is locked within the moon's ice shell. To understand how this ocean interacts with Callisto's icy surface, consider the freezing and melting cycles that occur within its ice shell. Heat from Jupiter causes the ice to melt, creating convection currents in the ocean beneath. These currents, driven by Jupiter's gravitational pull, mix the water and transport heat throughout the subsurface ocean. But as Callisto moves away from Jupiter during its orbit, temperatures drop, causing the top layer of the ice shell to freeze again. This cycle of freezing and melting can cause instability in the subsurface ocean, making it challenging for life to thrive there. It's not just the presence of water that makes Callisto's subsurface ocean intriguing, it's also how it moves. Scientists have detected vast currents within this hidden world. One crucial factor influencing these currents is the gravitational pull of Jupiter and its other moons. These forces create tidal interactions that drive the water to flow within Callisto's interior. Additionally, heat from Jupiter's intense radiation affects the subsurface ocean, creating convection currents that mix and move water within this vast reservoir. But it gets even more complex. There's also the potential for these currents to interact with hydrothermal fluids. These fluids, superheated by geothermal activity deep within Callisto's core, could mix with the subsurface ocean water. The resulting mixture might carry essential compounds and nutrients that could potentially support life forms. These currents and their interactions paint a picture of an active, dynamic environment beneath Callisto's frozen surface. They hint at a world that is far from static, constantly in motion and change. Understanding these currents might just illuminate how this vast subsurface ocean could support life by circulating the essential compounds it needs to thrive. Tidal forces from Jupiter play a significant role in stirring up the icy layers beneath Callisto's surface. These forces create a constant ebb and flow, much like the tides we see on Earth. But it's not just the tidal pulls that shape this ocean. Convection currents, driven by heat from the core of Callisto, also contribute to the mixing. As warmer water rises and cooler water sinks, these currents help to circulate heat and other essential compounds throughout the ocean. Thermal gradients also play a part in driving this circulation. The differences in temperature between the warmer interior and the cooler exterior cause the water to move. These processes work together to create a complex system of currents that help maintain the chemical composition and potential habitability of this vast subsurface ocean over time. So, when we imagine life potentially thriving in this icy world beneath Callisto's surface, it's thanks to these dynamic forces that make the ocean a habitable environment. And as missions like Europa-Clipper delve deeper into this icy world, we might uncover even more secrets about the intricate dance of Callisto's ocean dynamics. For now, we marvel at the unseen forces that keep this hidden world alive and full of potential for life to emerge. Scientists are particularly interested in detecting biosignatures, specific chemical or biological compounds that could indicate the presence of life. Organic compounds, which contain carbon and hydrogen, are a primary focus. These organic compounds can provide clues about the conditions in Callisto's ocean. For instance, Detecting methane or ethane could suggest that life might be possible in this extreme environment. Beyond organic compounds, scientists look for biomarkers, molecules produced by living organisms. These can range from simple amino acids to more complex lipids and nucleotides. Detecting these biomarkers is challenging, but advanced techniques like mass spectrometry are invaluable. This method can identify the chemical composition of molecules with extreme precision, even at trace levels. Additionally, remote sensing techniques play a vital role. These methods can analyze light reflecting off Callisto's surface to detect specific wavelengths associated with organic compounds or other indicators of life. Imagine the excitement if future missions find evidence of such biosignatures on Callisto. This would revolutionize our understanding of life in the universe and open new avenues for exploration. But until then, we continue to marvel at the unseen forces that could make this hidden world a cradle of life. The potential is immense, and every new discovery brings us one step closer to understanding our place in the cosmos. The quest to unravel the mysteries of Callisto's subsurface ocean is far from over. Future missions hold the promise of revealing whether this icy moon might harbor not just water, but life itself. Callisto's surface is a tale of ancient impacts and tectonic shifts. The moon's dense cratering indicates a long history of celestial collisions, each one potentially driving heat into its interior. Scientists believe that the energy from these ancient impacts could have been enough to melt portions of Callisto's icy surface, causing temporary tectonic activity that would eventually cool and solidify. Tidal forces exerted by Jupiter could also play a role in Callisto's internal dynamics. The constant gravitational pull from the gas giant might cause tidal heating, further affecting the stability and chemistry of the subsurface water. Future missions like this hold promise for revealing how tectonic interactions on Callisto might influence the composition and potential habitability of its subsurface ocean. Understanding these processes is not just a scientific curiosity, but a crucial step in unraveling whether this icy moon might harbor life, a discovery that could reshape our understanding of the universe. The quest to understand Callisto's subsurface ocean and the forces that shape it continues, with each new finding drawing us closer to the heart of one of Jupiter's most enigmatic moons. At the heart of this question lies the cosmochemical composition of Callisto's ocean, the specific elements and their abundances that make up its waters. Key among these are hydrogen, oxygen, sulfur, and carbon elements critical to life as we know it. Let's dive into the presence and abundance of each. Hydrogen, the most abundant element in the universe, is no exception in Callisto's ocean. Its high concentration suggests a rich environment for potential biological processes. Oxygen, essential for respiration and cellular metabolism, is another crucial component. Though its abundance in Callisto's ocean might be lower than that of hydrogen, it plays a vital role. Sulfur, while not as abundant, is also present and significant. Its compounds can act as electron donors or acceptors, supporting various biochemical reactions. Carbon, the backbone of organic molecules, is yet another key player. Its presence suggests the potential for complex organic compounds to form within this extraterrestrial environment. These elements, hydrogen, oxygen, sulfur, and carbon together paint a picture of an ocean that is not only vast but also chemically rich and complex. But their presence alone isn't enough to determine habitability. We must consider how these elements interact and whether they can support the delicate dance of life. The Europa Clipper mission and future endeavors will undoubtedly shed more light on the cosmochemical composition of Callisto's ocean, helping us piece together this cosmic puzzle. In doing so, we might just unlock one of the greatest mysteries in our solar system, the possibility of life beyond Earth. As these particles collide with the surface, they don't just bounce off, they interact chemically, embedding themselves into the ice and rock. Over time, this process has enriched Callisto's surface with a variety of elements that would otherwise not be present. This constant influx of cosmic dust has significantly contributed to the composition of Callisto's subsurface ocean. As these particles migrate downwards through the ice and rock layers, they introduce a rich array of compounds that might be essential for life as we know it. Scientists have long theorized about the potential habitability of this hidden ocean, and the presence of cosmic dust could be a key factor in that equation. The elements brought by these particles could provide the necessary building blocks for biological processes. But before we get too far ahead of ourselves, it's important to remember that life as we know it relies on a complex interplay of many factors, not just the presence of these elements. The conditions deep within Callisto are harsh and unforgiving. Still, the fact that cosmic dust is continually shaping and enriching this subsurface ocean offers a fascinating glimpse into how our solar system's raw materials might come together to support life in unexpected places. And so, as we continue to explore the depths of Callisto and its secret ocean, we are reminded that the universe is full of surprises. Some as tiny as cosmic dust, yet with the potential to create something as immense as a hidden world teeming with life. Impact events can significantly alter a moon's surface and interior structure. The energy released by such collisions can lead to intense heating, which could potentially melt and reshape the ice layers that encase Callisto's ocean. However, the frequency of these events is relatively low, occurring over geological timeframes measured in millions or billions of years. Another factor influencing the stability of Callisto's ocean is tectonic activity. While Callisto is not known for active tectonics, its surface has experienced some degree of deformation over its long history. These subtle shifts could affect the overlying ice layers and the ocean's long-term stability. As we explore the geological stability of Callisto's ocean, it becomes clear that the moon's vast and potentially habitable world beneath its icy crust is subject to complex forces. The challenge for scientists is to unravel how these events influence the long-term stability of this enigmatic environment. Imagine a calm sea, seemingly undisturbed by the winds above. Yet beneath the surface, currents stir and life thrives unseen. In this sense, the stability of Callisto's ocean is not just about its physical integrity, but also about the conditions it maintains for potential life forms. The geological stability of Callisto's ocean offers a glimpse into the resilience of worlds beyond our own. As we continue to uncover the secrets of this icy moon, we gain a deeper appreciation for the cosmic dance that shapes and sustains life throughout the universe. These biogeochemical cycles involve the cycling of carbon, nitrogen, and sulfur elements vital for life as we know it. Carbon, in particular, is essential for the building blocks of life. Scientists speculate that hydrothermal activity on Callisto could influence these carbon cycles, potentially creating environments conducive to life forms. Similarly, the nitrogen cycle is crucial for forming amino acids and nucleic acids, the building blocks of proteins and DNA. Understanding how nitrogen is processed in Callisto's subsurface ocean could provide insights into the conditions necessary for life to emerge. Sulfur, too, plays a significant role in these biogeochemical cycles. It is often associated with hydrothermal vents, which are known to support unique ecosystems on Earth. Imagine the possibilities. A sulfur-rich environment within Callisto's ocean could foster microbial life, thriving in conditions vastly different from those on our own planet. In this cosmic ballet, each element dances with another, creating a delicate balance that could either nurture or stifle the spark of life.